All right, here we go, guys. We're going to jump into 6.2 multiplying polynomials. A lot of this should look familiar to you guys, so we'll do some practice here together and practice naming and classifying. So as we start on example 1, this is multiplication. You can tell by the parentheses, so we're going to go ahead and multiply negative 3 times negative 2x squared. That's going to get us a positive 6x squared. Remember, if 3 had any x's with it, we would just go ahead and add those exponents up. Like example number 2. I've got a 1 here, so I'm going to do 5 times 1 is 5. And then I have x to the third and x to the second. And when you multiply the same base, you're essentially just adding those exponents up. So we're going to do 3 plus 2 is 5, so 5x to the fifth. In example 3, we're going to again multiply 6 and negative 3 is negative 18. And then we're going to add up these x's. If it doesn't have the exponent, just like the coefficient out in front, the exponent is a 1. So then that's going to get us x to the fifth when I add up 1 and 4. All right, so when I look at example 4, we're just going to make our problems a little larger here. We're going to add a few more variables. This is the same thing, though. We're just taking this term and distributing through. Remember, we're adding exponents, we're multiplying the coefficients. So when I start with this first term, 3 times 4 is 12, and I know I'm going to have x's and y's left over. So when I look at my x's, I've got 1, 2, 3 x's. Remember, if there's not an exponent, it's an assumed 1. And when I look at my y's, I've got 2, 3 y's to put together. So that should be our first term here. Then I'm going to go on to the next. 3 times negative 6 is negative 18. So we're going to have a minus 18. And then we're going to put our x's together. Here's 1 and 2 x's. Remember, they both have an exponent of 1. And then there's 3 y's. Remember, just because there's a number out here doesn't mean there's not a number there. There's always a 1. All right, and then let's look at that next term. 3 times 14 is a positive 42. And when I add up my x's, I'm going to have 4 of them. And when I add up my y's, I will also have 4 of them. Okay, so when I'm talking about classifying, I actually want to take my highest degree in order to classify, which means in terms, you're adding up your exponents. So in this term, this is actually an 8th degree. This term is a 5th degree because I add up 2 and 3. This term is a 6th degree. So just like we always set up standard form, we set up highest degree first. Remember, it always goes x squared, x, then a constant. So we actually set up our standard form highest degree first as well. So that's going to be 42 x to the fourth, y to the fourth comes first. Then plus 12 x to the third, y to the third comes second. And then minus 18 x squared, y to the third is going to be our last term there. And so our classification always identifies the degree and how many terms there are. So in this case, my highest degree, this is an 8th degree. And then there are 1, 2, 3 terms. So this is an 8th degree trinomial. Remember, anything after 3 is just a general polynomial. So let's look at example 5 here. And now I've got 2 terms to distribute. Now, once we start adding in 2 terms into more than a binomial, it does get fairly lengthy. So I'm going to show you this trick where essentially we make one string of numbers, but we're going to stack them up to save us some time. So just like before, I'm going to take that 2x and I'm going to multiply all the way through. So 2x times 3x squared is 6x to the third. 2x times negative 10, negative 20x squared. And then 2x times 6 plus 12x. All right, we've used that purple. So now I'm going to change it to green, and I'm going to pick up that negative 5 for our distribution. And we're going to get negative 5 times 3x squared, which is negative 15x squared. So we're going to save a step, and we're just going to set it underneath our x squareds. So what you're going to see is after your first term is multiplied through, you're always going to end up combining with your second term. Or you can just find what your term should be and match it up, right? So then I've got negative 5 times negative 10x. So that's going to be positive 50x. And negative 5 times 6, so negative 30. So notice how they all do line up. And then we'll just add them up, essentially, to help us combine our like terms faster. So then we'll have 6x to the third, negative 35x squared, positive 62x, and negative 30. So this is already going in descending order from highest exponent down. So that's going to be our standard form. And we classify that with our highest degree, which is a 3, so cubic. And then there are 1, 2, 3, 4 terms, so we just get a general polynomial. All right, let's check out a couple more of these. So I'm going to multiply this one out. Again, this means, just like before when we would work on these, this means we have to write this 3 times. All right, so here's what I would suggest doing is I would go ahead and just multiply 2 of these out and leave the other one out. Then we'll multiply that one in after. So I'm going to multiply this 4x times 4x, 16x squared, then negative 8x, and positive 4. All right, so now we have 4x minus 2 times 16x squared minus 16x plus 4. So all we did was multiply 2 out of the 3 of them, and then we have our third one here ready to distribute through. So we're going to use that same trick that I taught you before. We're going to take our first term and distribute. So that's going to get us 64x to the third minus 64x squared plus 16x. Then I'm going to use a different number to show, or a different color to show. We're going to now pick up the negative 2, and I'm going to put it underneath to combine like terms. So negative 2 times 16x squared is going to go right here under the x squareds. So negative 32x squared. Then positive 32x and negative 8. And now we can just add those up. So 64x to the third minus 96x squared plus 48x minus 8. All right, highest term is a 3, so I've got a cubic, and there are more than 3 terms, so anything after that is a polynomial. So another cubic polynomial. All right, and let's try one more practice problem here with just distribution. So I'm going to use the same skill. I'm going to use 3 different colors here, which means I'm going to have 3 different lines. So x squared times x squared, x to the 4th, plus 5x to the 3rd, minus 2x squared. Then we'll pick up our negative 4x. Negative 4x times x squared is negative 4x to the 3rd, lining that up with the x to the 3rd. Negative 4x times 5x is negative 20x squared, and then positive 8x. All right, and then we just got one more to distribute through. So let's go red. So we're going to take that 1 times x squared. So we're going to get an x squared here, and then 1 times 5x, so plus 5x minus 2. All right, so this is just, if you guys want to write it out in a big string of numbers and circle them up, that's a-okay. Here's just another way to stack them up to do your like terms part a little easier. So then x to the 4th comes down. X to the 3rds, we've got 5 plus a negative 4, so that's 1x to the 3rd. And then x squareds, we've got negative 2 minus 20 plus 1. So that's going to be minus 21x squared. And then 8 plus 5 to get us 13x, and then minus 2. So this would be our standard form here. Big old honking guy. Standard form. So first term is a 4, so that's going to make it a quartic. And then we definitely have more than 3 terms, so still just a polynomial. Remember, 1 term is monomial, 2 term is binomial, 3 term is trinomial, and anything after that is a polynomial. Now this question on number 8 says, hey, what's the difference between 8 and 7? Well, if you look at 8, that's an addition problem, okay? You look at 7, there's no sign in between. That is a multiplication problem. So remember, on addition, we're just putting together our like terms. So I'm going to go 1x squared plus 1x squared to get 2x squared. I'm going to go negative 4x plus 5x to get positive x. And then 1 plus negative 2 to get minus 1. So remember, if we're adding or subtracting, we're just combining like terms here. All right, guys, make sure to ask us questions where you have it, and good luck. Time to get mathy.